This video covers chapter 4 of the Collins GCSE book, chapter 4, and lots of these things overlap. So we'll start with simplifying a ratio. That's nice and easy. So that's just two numbers in a ratio. I don't know, 50 and let's say 45, and dividing both the numbers in a ratio by the same thing. We normally want to find something called the highest common factor. That means that we'll actually be able to simplify in one step. So for example, here I can divide these both by 5 and I end up with a ratio 10 to 9. Okay, so very easy simplifying a ratio. If we want to do calculations with ratios, which is the next bit here, quite often a worded problem can be turned into a ratio problem. So let's say in a class the ratio of boys to girls is 4 to 5. Okay, and the question is, if there are 15 girls, how many boys are there? How many boys are there in a class? Well, the way that would do this question is we'd start by writing down, okay, so this is boys to girls, so we write this down like this. We'll write down the ratio, which is 4 to 5, so we'll write this down like this. And this extra bit of information tells us that there are 15 girls. We'll do that. And we need to find how many boys there are. So basically it's like we call it equivalent ratio. So we can work out what we need to multiply here. This needs to be multiplied by the same thing, which means that missing number is 12. So the answer to the question is that there are 12 boys. And if the question said how many students are there in a class, well then what we would do is we would just add these two numbers together. So we know that there's 27 altogether. 27 students in a class, if the question was asking that type of thing. So here we have compound measures. Now compound measures are made up of more than one unit, like miles per hour, meters per second, newtons per meter squared, grams per cubic centimeter. Yeah, these are all compound measures. They're measures for speed, measures for pressure, and the last one is a measure for density. Now we do need to know the formula triangles for speed, distance, time, density, mass and volume, and force, pressure and area. So you should know how to use the formula triangles. I'll just put them here. So speed is distance over time, density is mass divided by volume, and pressure equals force divided by area. Now because these the units are normally fixed types of units, so we do meters per second, we don't do like meters per minute or meters per hour. We normally use like meters per second or grams per cubic centimeter. We do need to know how to convert, particularly these ones can be tricky, converting between centimeters squared and meters squared, and converting between centimeters cubed and meters cubed. So how do we do that? Well, if I want to change centimeters to meters, I would divide by 100, but since this is a square unit, I divide by 100 squared. Here, if I want to convert meters to centimeters, I know that what I'd normally do is times by 100, but since it's a square unit, I times by 100 squared. If I've got centimeters cubed and meters cubed, similar type of thing. So centimeters to meters would be divide by 100, but it's a cubed unit, so I divide by 100 cubed. So if I go that way, I times by 100 cubed. So it's useful to be able to convert between those units. So we've just had a look at speed, distance and time there. That means we can do types of calculations, and here we have density and pressure. Right, what next? So the next thing we're going to be looking at is like this best buy type problems here. Okay, so best buy. Okay, so if we're going to do best buy problems, the best way to do it is to find the cost of one item or 1 gram or 1 kilogram, something like that, something that's going to allow you to be able to compare the price of different things. So let's say I went into a shop and there was a can of soup like this, a small can of soup that was 300 grams, and a bigger can of soup that was 500 grams. Yes, this is soup in here. And let's say that the small can of soup that cost £1.49, and the large can of soup costs £2.10. And the question is, okay, which one of those is the best value for money? So what we're going to do is we're going to find the cost of let's say 1 gram of soup. So here I've got 300 grams, here's 149. So that means that if I want to find a price of 1 gram, that means I need to divide the cost by 300. So I'm writing like this, and I'm going to use decimals in my answer. These divides don't look very good. Let's try those again. So divide, divide. So if I do 149 divide by 300, so 1 gram of soup comes up as a decimal, so it's 0.0 oh, too many noughts, 0.00496 pence per gram, or pounds per gram, but let's just put that there, and we'll do the same for the big can of soup, 500 grams for £2.10. So I want to find the cost of 1 gram, so I'm going to divide both of these by 500. Divide by 500. I think the last answer was pounds and pence, since I started with pounds and pence. So I think actually 1 gram is equal to 0.496 pence, and I think the 6 recurs at the end. So if I do £2.10, 2.10, divide by 500, press SD, and what I get is 1 gram equals 0.0042, which is actually, times that by 100, 0.42 pence per gram. So from these values here, we can work out which one is the best value. Now the best value is the one that costs less per gram, and that's going to be the large jar. Don't always assume the large things are best value, they're not always. So by working out the cost of 1 gram, or it might be one item, whatever it is, 1 biscuit, 1 egg, then we can compare them. You can't compare them otherwise. So my conclusion for this one is that the 500 gram tin is the best value. And we need to show our working. You can't just say it's the best value without any working. Right, okay, so interest now. I think all the rest of the problems are to do with interest. You've got simple interest, we've got compound interest, we've got complex problems involving percentage increases and decreases, complex problems there to do with compound interest, and then after that we'll look at reverse percentages. So percentage interest comes in two types. Okay, simple interest and compound interest. Simple interest, if I started with, I don't know, if I had £100 and I had £100 at 6% simple interest, all that would mean is that every year I would get 6% of 100 added on. So every year I would get added on 6% of 100 is £6. So every year I would add on £6 to what I started with. So I started with 100, add on 6. After a year I got £106. Add on 6 again. After you got 112, add on 6 again. After 3 years I've now got 118, and so on. With compound interest, we're going to be using multipliers. So if I had, let's use the same interest again. So if I had £100 invested at 6% compound interest, then what we do is we start with £100. Then the next year, to work out what I get in the next year, I actually times by 1.06. So that tells me I've got an increase of 6%. So if I do 100 times 1.06, I get £106. Same as with the simple interest, but then it changes. So now I'm going to times by 1.06. So I'm now going to work out 6% of 106. So 106 times by 1.06. So after 2 years, I now have £112.36, which is a bit more than when I had the simple interest. I've just got £112. Let's see how much we get after 3 years. So 112.36 times by 1.06 again. Now I get £119 and rounded to the nearest penny and 10 pence. So you can see with the compound interest, you get a little bit more than you would with a simple interest, because you're not working out 6% of 100, you're working out 6% of the last amount that you've got. Now, if I did this for lots of years, I don't want to keep multiplying by 1.06. I can do this. Let's say I wanted to know how much I had after 10 years. I would do this. Times by 1.06 to the power 10. So the power here is going to be the number of years. The power is the number of years. Some questions it might be you increase or decrease by a certain amount a month. So it might be that number stands for the number of months. Okay, last thing we're going to look at is now reverse percentages. We've done everything else. Reverse percentages. And to do reverse percentages problems, reverse percentage, we're going to use, there's lots of different methods to do it. You could actually use multipliers in reverse to do it, but I'm going to show you a different method. So reverse percentages. So let's say, and we've got this type of question. These questions are always worded the same way. So after a sale of 7% off, a pair of trousers costs £74.40, so some very expensive trousers. So it's important to note these types of reverse percentage problems start with after something. We've got a cost. Then the question always goes on to say, what was the price before the sale? So that's really important as well, because it will have this word or phrase, well, what was it before? And this is what we do. So what we're going to do is we're going to call the original price, or it might say what was the price before, it might say original price here. We're going to call the original price, which we're trying to find 100%. So this is the method. Yeah, and we always do that. Call the original price 100%. Now, if the original price is 100% and in the sale 7% was taken off, we're now at 93%. So what we're going to do, we're going to call this £74.40. We're going to call that 93%. So £74.40 equals 93%. Then what we're going to do, we're going to divide by 93 to work out what 1% is. So divide by 93, divide by 93. So if I do 74.40 divided by 93, I get 1% is 0.8. So 0.8 is going to be 80 pence. So I've basically got this 0.8. That's 1. And then from here, I times by 100 because I want to find 100% the original price. So times by 100, that should be easy enough. I end up with £80, which is 100%. So that's the original price. Okay, so the original price was £80. And these types of questions, they normally work out, the original price normally works out to be a nice round number rather than some funny decimal. You may start off with a funny number, but you normally end up with a nice, easy answer. Very last thing we're going to look at here is complex problems involving percentage decreases and increases. Very, very straightforward. Sometimes you are given a starting amount, sometimes you're not given a starting amount. If you're not given a starting amount, so let's say we had a question like this. A car is, or a car price is increased by 15%, then decreased by 17%. Yeah, and the question might say, is the new price, oops, this one is not very good, is the new price more or less than the original price? That's the question. So we're not given a starting amount for the car. So I would always say start with 100, and then our final answer we can compare to 100. So if it's increased by 15%, we're going to times this by 1.15. That's an increase of 15%. And then if it's decreased by 17%, we multiply it by whatever 100 minus 17 is, which is 0.83. That as a decimal is 0.83. So the first figure here, that's my increase of 15%. There. This is my decrease of 17%. And what I'm going to do is to work this out and compare it to 100. So if I do 100 times by 1.15, then immediately times it by 0.83, I end up with 95.45. 95.45. Now I can see that actually if I start at 100 and I've gone down to that, the actual car costs less. Car costs less now. And I could actually say how much less. If I think of the 100 at the start, like 100% here, and I've gone down to this, well, all I need to do is to work out how much it's dropped by. So if I actually do 100 minus 95.45, I can use those numbers. I can say it's actually dropped by 4.55%, yeah, and be really clever with my answer. Car costs less, and I could say, in fact, the price has dropped by 4.55%. Okay, and that now finishes the revision for this chapter.